This is Unit 9, Lesson 3. We're going to talk about geometric sequences. You can take a minute here and pause it and read over the objectives. Basically, we're going to learn how to write these geometric sequences using explicit and recursive formulas. And with the formula, we'll be able to find specific terms in a sequence. Okay, so first I'm going to use inductive reasoning to describe each pattern. Then find the next two numbers in the pattern. So inductive reasoning basically uses patterns to help you generalize what could happen next. Okay, so if I look, I have 2, 5, 8, 11. So I can say, okay, I'm adding 3 each time. So add 3. Then the next two numbers, okay, will be 14 and 17. Okay? Here, 2, 4, 8, 16. So adding, this would be here to here would be plus 2, here to here would be plus 4. So I'm not adding the same thing every time. What I'm doing is multiplying by 2. So okay, then the next two numbers, 16 times 2 is 32, 32 times 2, 64. Okay. All right, now I want to find the common ratio of each geometric sequence. So geometric sequences is where you multiply or divide every time. But with division, we say multiplication by a fraction. So like when you're dividing by 2, really what you're doing is multiplying by 1/2. So we only use multiplication. So if it looks like the numbers are going down, if it looks like we're dividing, then really what we're doing is multiplying by a fraction. Okay, so geometric sequences multiply by a common ratio. All right, so looking here, to figure out what you're multiplying by going forward, we're just going to divide backwards. So if I do -6 divided by 2, that's 3. -18 divided by 6, that's 3. Those should be the same. So my common ratio is 3. Okay. Now it might not be quite as obvious, so we might have to get out our calculator. And we're going to divide backwards. So 22.5 divided by 18, that's 1.25. And then let's check and make sure it's the same thing here. 28 divided by 22.5. Oh, sorry, 28.125 divided by 22.5. That was also 1.25. So my common ratio, 1.25. So to know what you're multiplying by going forward, we divide backwards. Okay, so if we are using a geometric sequence, we have two formulas for those. One is called the recursive formula. So your a sub 1 is the first term. So the way I said that was a sub 1. So the sub stands for subscript because it's a little number. So a sub 1 is our first term, so the first number in the sequence. Then a sub n, so to find any term, you're going to do r, your common ratio, and then your a sub n minus 1. So this means previous term, so the term right before it. Okay, so I'm going to want to write the recursive formula. So I'm going to want to write what a sub 1 is. And then I'm going to do this. So when I write out a formula, I write out this. I put my first term here. And then I plug in R. Everything else stays the same when I'm writing it as a formula. Okay, so a sub 1, my first term in my sequence is 4. And then a sub n equals R, so I need to figure out what my common ratio is, so let's divide backwards. So it looks like for R I'm getting 3. And this is my recursive formula. Okay, we're going to do the same thing on this next example. So a sub 1, my first term is 12. And then a sub n equals R, so I have to figure out what R is. So I'm going to divide backwards. And I got 0.75, or you can write it as a fraction, 3 over 4. And then times a sub n minus 1. And there's my recursive formula. Okay, so once we have the formula, then we'll be able to write out the first few terms. The next thing we're going to do is look at the explicit formula. So when you do the recursive formula, what we just did, you have to have the previous term in order to find the terms. The explicit formula, this one, you can find any term. So really the same way, but this is a of n. That looks more like function notation. A of n. But we still have our a sub 1, our first term, and then we have r, which is our common ratio, and then n minus 1. So notice how this n is not attached to an a. So that n is really meaning term number. That tells you what position in the sequence you have. Okay. So we're going to do these same sequences again, but this time we'll write the explicit formula. Alright, so that was a of n. It also could be a sub n, that's okay too. Equals a sub 1 times r to the n minus 1. So again, I am, for the formula, only filling in the first term and the r. Everything else stays the same. So this equals 4 times 3 to the n minus 1. Now I will caution you a little bit about that exponent with the n minus 1. We really should get used to doing parentheses around the 3. Oh, sorry, 3 parentheses. Because if that common ratio is a fraction or negative, then our calculator will not calculate it right unless it's in parentheses. Okay, so same thing over here. Oh. So I have a of n equals 12. And it is 0.75, but I'm going to write it as a fraction this time, so 3/4. Remember, if you have a graphing calculator, to change your fraction or your decimal to a fraction, you just hit math, enter, enter, and it's 3/4. Or you can hit your ABC, your second ABC button if you have just a little scientific calculator. So 3/4 to the n minus 1. Okay. All right, so I'm going to say what formula it is, if it's recursive or explicit, and then I'm going to write the first 4 terms. Okay, well, the giveaway that it's recursive is that you have these 2 lines. You have one line for your a sub 1 and then one line for your a sub n. All right, so first 4 terms. So obviously I know the first term is 6. And then the formula says I'm going to do 5 times the previous term. So if I want to find the second term, a sub 2, I do 5 times the previous term, which would be 6. And that would be 30. Okay? And then I'm going to do 5 times 30. The previous term for a sub 3, the previous term would be the second term. So 5 times 30 then is 150. Okay, now pause it and go ahead and find the fourth term, 750. And I needed to say that this was a recursive formula. B, there's only one line here. This is explicit. Okay, so I have to be able to pick out what part was what. So this is my first term, and then my common ratio is 2. So really what we're doing is if you want to find the second term, you're doing a of 2. That's just saying you want the second term. 3 times 2, and then you have that 2 minus 1. Now, if you have to type this in your calculator, go ahead and do the exponent, like that subtraction, in your head. 2 minus 1 is 2. So when I go to type it in, I'm just doing 3 parentheses 2, and I'll use my caret key, and then I'll do 2 minus 1 in my head and just type in 1. And it's 6. Or I can recognize, okay, my common ratio, this part right here, is 2, which means I multiply by 2 every time. So then 6 times 2 is 12, 12 times 2 is 24. Okay, now this last one, recursive, there's 2 lines. So pause it and list out the first 4 terms. Okay, so you should get -4, -2, -1, -0.5. So you have your first term is -4, and then your r, 0.5, or 1/2. You're multiplying by 1/2 every time. Then it will give you those first 4 numbers there.